In the middle of one of the harshest deserts on Earth, where the sun scorches the ground and wind carves dunes into endless waves, Israel accomplished something that almost defies belief. This is not a fantasy or a scene from a futuristic film. It is a real-life story of how science, engineering, and sheer human determination turned a barren wilderness into a land flowing with water. The Negev Desert, once a symbol of desolation, has become a testament to what is possible when people refuse to accept nature's limits. This is the story of how Israel brought the sea to the desert and gave birth to an artificial river system that changed everything. The story begins in the blazing heart of the Middle East. For centuries, the Negev was seen as an unforgiving wasteland. During summer, temperatures soared beyond 110 degrees Fahrenheit. Rain came only for a few short weeks each year, and the underground aquifers that once sustained life were drying up. Nothing seemed to survive here for long. Crops withered, livestock perished, and farmers gave up their ancestral lands. Villages that once thrived became ghost towns, their wells reduced to dust. Water had to be trucked in from faraway regions, a costly and unsustainable effort that kept entire communities barely alive. But just beyond this endless sea of sand lay another sea, the Mediterranean. It was vast, blue, and brimming with salt water. To many, it was useless for human consumption. Yet to Israeli scientists and engineers, it represented an opportunity. The question that drove them was simple but bold. What if we could bring this sea into the desert? What if salt water could become sweet and dry land could bloom again? In the early 2000s, this daring vision became official policy. The Israeli government launched what would later be called the Desert Water Project, an engineering plan so ambitious that it seemed like an attempt to rewrite nature itself. The investment was enormous, around $3 billion, but the goal was clear: make rivers flow through sand and turn the sea into life. The first challenge was not technology, it was the desert itself. The Negev's unstable sand dunes made construction almost impossible. Every gust of wind could erase months of progress overnight. Engineers knew that before a single canal could be dug, the ground had to be tamed. So they began by mapping the land using high-resolution satellites and ground-penetrating radar, studying every inch of terrain. They drilled boreholes more than 100 feet deep to understand the layers beneath. Nothing was left to chance. Every step, every slope, and every curve of the future canal was calculated down to centimeters. Next came the transformation of the terrain. Hundreds of bulldozers, graders, and excavators moved into the desert. They leveled ridges, filled depressions, and reshaped the landscape to create a solid foundation for construction. Moisture became a key ally. Engineers discovered that by spraying groundwater across the sand, they could make it bond together. Once damp, heavy rollers compressed it into a tough, compacted surface capable of supporting the massive weight of cranes and trucks. Bit by bit, the desert began to look less like a wild expanse and more like a colossal construction site. Then the digging began. Every day, more than 70,000 tons of sand and soil were excavated. Over 1,200 engineers and laborers worked under the blinding heat of 115 degrees Fahrenheit. The main canal stretched roughly 250 miles, averaging 150 feet wide and 23 feet deep. The precision required was extraordinary. The slope could not vary by more than 1 inch over every 100 feet, or the water would not flow correctly. Laser-guided leveling systems maintained this accuracy over the entire stretch, and the removed sand was recycled to build high embankments on either side. But there was another, even greater problem: the desert's thirst. Any canal left unsealed would simply lose its water to the porous ground beneath. To solve this, Israel built one of the most extensive waterproofing systems ever attempted in the region. The canal bed was first leveled, then covered with concrete panels 4 to 5 inches thick, each measuring 16 by 10 feet. Between them, expansion joints filled with bitumen allowed for temperature fluctuations while preventing leakage. In weaker soil zones, engineers added a high-density polyethylene membrane beneath the concrete and anchored it with steel rods. The result was a completely sealed waterway that could hold billions of liters without losing a drop. To further protect the structure, they planted vegetation along the canal banks. Species like vetiver grass and desert acacia were chosen because they could survive extreme heat while stabilizing the soil. Their roots prevented erosion and kept the sand from being blown into the waterway. From above, the finished canal appeared like a shining silver ribbon cutting through an ocean of gold. It was beautiful and strange, a river where no river had ever flowed. This was not just a canal, it was an entire hydraulic ecosystem. Along its length, engineers built hundreds of supporting structures: bridges, siphons, aqueducts, spillways, and culverts. These were designed to handle everything from seasonal floods to maintenance transport. Every few miles, massive steel gates regulated the flow into secondary branches, ensuring a precise balance across the network. In essence, Israel had created an artificial river system controlled by machines and mathematics rather than rainfall and geography. After 15 years of relentless work, the time came for the ultimate test: water release. Engineers opened the gates cautiously, starting with low discharge rates and increasing gradually. Sensors tracked every fluctuation: pressure, temperature, salinity, and soil movement. For hours, they watched the numbers on their screens until finally, the impossible happened. A wave of seawater rolled across the empty canal. For the first time, the Negev desert echoed with the sound of flowing water. Villagers and construction workers gathered to witness what they called the rebirth of the desert. Cameras captured the shimmering flow spreading through the channel as if life itself was returning to the sands. Old farmers wept. Children splashed in the shallows. It was a moment of triumph, not just for Israel but for human ingenuity everywhere. Yet this was only half the journey. The water flowing through the canal was still salty and undrinkable. To make it usable, Israel turned to one of the most advanced desalination systems in the world. On the country's Mediterranean coast, massive desalination plants had been quietly developed over the years. Now, they were ready to play their part in this grand design. Inside these facilities, seawater first goes through mechanical filtration to remove sand and oil residues. Then it passes through nanofiltration units that trap smaller impurities. But the real magic happens in the reverse osmosis chambers. Here, high-pressure pumps force the water through ultrafine membranes that allow only pure H2O molecules to pass, leaving behind salts, heavy metals, and other contaminants. What emerges is clean, clear, and safe water, but almost too pure. It lacks the natural minerals our bodies need. So the engineers reintroduce essential elements like calcium and magnesium to balance the taste and health properties. After that, ultraviolet light and ozone disinfect the water completely, and a trace of chlorine is added to keep it fresh during long-distance travel through pipelines. Every aspect of the process is digitally monitored: pressure, pH, flow rate, and purity, in real time, 24 hours a day. Once it meets the highest standards, the desalinated water is released into massive underground storage tanks and then into the main canal system. From there, it travels hundreds of miles across the desert, reaching cities, factories, and farms. What was once an impossible dream was now a daily reality: seawater transformed into drinking water and nourishment for an entire region. The effects were immediate and profound. Within a few years, barren land began to bloom again. Farmers returned to cultivate crops where nothing had grown for decades. Drip irrigation systems, another Israeli innovation, delivered precise amounts of water directly to plant roots, minimizing waste. Fields of green spread across the sand, and villages that had once been abandoned came back to life. Schools reopened, businesses re-emerged, and for the first time in generations, the desert looked alive. From space, satellites captured the astonishing transformation. Where there had once been nothing but brown and gold, a bright green ribbon now cut across southern Israel, a living vein of water feeding towns and farms. It was a human-made miracle, proof that the boundary between possible and impossible depends only on willpower and vision. As the Negev continued to flourish, it became clear that Israel's transformation was far more than an engineering success. It was a redefinition of survival itself. For decades, the desert had been seen as the limit of what human civilization could endure. But now, fields of oranges, vineyards, and rows of date palms stretched across what was once barren earth. The same land that had cracked open under the sun was now bursting with life. Farmers who once fled the desert were returning, drawn by a promise fulfilled. Their grandparents had dreamed of this moment, and now it had become their reality. But this achievement didn't come out of nowhere. It had deep roots in Israel's long history of water innovation. Back in 1953, decades before the Desert Water Project, Israel had already launched the National Water Carrier, a groundbreaking infrastructure designed to transport water from the Sea of Galilee in the north to the arid south. The system was the country's first major attempt to balance its water distribution, ensuring that every drop could serve multiple purposes: agriculture, industry, and domestic use. It took 11 years to build and cost around 420 million Israeli lira, a staggering amount for a young nation still struggling economically. Yet it was completed in 1964, capable of transporting up to 72,000 cubic meters of water per hour. That project laid the foundation for everything that followed. The National Water Carrier gave birth to a culture of water management that has no equal today. Every citizen became part of a national effort to conserve and respect water. From urban households to desert farms, the focus shifted toward efficiency. Technologies like drip irrigation, developed by Israeli engineer Simcha Blas, revolutionized agriculture worldwide. His system allowed farmers to deliver tiny amounts of water directly to plant roots, reducing waste and increasing yield. This invention turned Israel into a global model for water efficiency long before desalination took center stage. When desalination technology matured, Israel was ready to lead. Its engineers refined reverse osmosis to an art form, constantly reducing costs while increasing output. In just a few decades, the country built a network of massive desalination plants along its Mediterranean coast, including facilities like Sarek, Hadera, and Ashkelon, each capable of producing over 150 million cubic meters of clean water every year. Together, they now supply nearly 80% of Israel's domestic water needs. The idea of water scarcity, once a national nightmare, has been replaced by abundance. But Israel didn't stop there. It created a system of recycling and reuse that turned wastewater into a valuable resource. Nearly 90% of Israel's wastewater is treated and reused for agriculture, the highest rate in the world. The treated water irrigates vast fields, supporting everything from citrus groves to vineyards. What most nations throw away, Israel turns into life. This holistic cycle, from desalination to recycling, ensures that not a single drop goes to waste. The Desert Water Project, combined with desalination, became the final link in this chain of innovation. The idea was not only to bring water to the desert but to make the desert sustainable forever. Along the canal, engineers installed automated sensors connected to central control systems. These devices monitor every element of the network: flow rate, temperature, pH, and mineral content. Artificial intelligence predicts usage patterns, detects leaks, and automatically adjusts gates and valves to maintain balance. It is a self-regulating, living infrastructure, a water system that thinks for itself. The results are visible everywhere. Cities like Beersheba, once a dusty outpost, have become thriving urban centers with parks, fountains, and gardens. The region's industries, from food processing to technology, depend on the steady water supply from the desert canals. Solar farms line the horizon, powering desalination plants with clean energy. What began as a survival project has evolved into an environmental model, water and energy working together to sustain life in one of the world's toughest climates. The transformation also changed the way the world sees Israel. Countries from Africa to the Middle East, from India to California, began studying its model. Delegations arrived to learn how a nation with so little natural water managed to achieve full water independence. Many of them adopted Israel's methods, desalination plants, drip irrigation systems, and wastewater recycling programs, proving that the principles developed in the Negev could help solve global water crises. Yet behind every success story lies sacrifice. The Desert Water Project took more than 15 years to complete, involving thousands of workers, scientists, and engineers who lived for months under brutal desert conditions. Many endured heat stroke, sandstorms, and long separations from their families. But the vision that kept them going was clear. One day, their work would make a desert bloom. Their perseverance paid off. The project's completion marked not just a technological milestone but a spiritual victory. When the first clean water reached remote desert villages, children ran to fill their bottles. Schools held ceremonies to honor the workers who had made it possible. For the first time, people could grow their own food, drink safely, and plan for a future that wasn't dictated by drought. The symbolism of this achievement runs deep. In the heart of the Middle East, a region often defined by conflict and division, Israel's canal and desalination systems became symbols of cooperation and hope. Water, once a cause of tension, began to represent the possibility of unity. Israeli engineers now share their expertise with neighboring countries like Jordan and Egypt through joint water initiatives. The Negev, once a dead zone, is now a bridge of connection across borders. From an environmental perspective, the impact has also been remarkable. The reintroduction of water has brought back wildlife long thought gone. Birds have returned to migrate along new green corridors, and oases have formed around reservoirs and irrigation ponds. The desert ecosystem, though artificial in origin, now supports biodiversity on a scale unseen in generations. Still, the story is not without challenges. Maintaining such a vast network in the middle of a desert requires constant vigilance. Sandstorms can damage infrastructure, and the long-term environmental balance must be carefully managed to avoid overuse of energy or disruption of natural groundwater systems. But Israel's engineers continue to adapt, integrating renewable energy sources and developing more efficient membranes and pumps for desalination. Each improvement makes the system more sustainable and less dependent on fossil fuels. As the decades passed, the Negev Desert evolved into more than a region. It became a living laboratory for the future. Scientists study its transformation to understand how climate resilience can be achieved in other arid parts of the world. The lessons learned here are now shaping policies in regions like North Africa, the Arabian Peninsula, and even California, where drought threatens millions. For the people who live in the Negev today, the canals are more than just infrastructure. They are lifelines, reminders of how human determination can bend even the harshest environments to serve life. Standing beside these waterways, you can see farmers tending to greenhouses filled with tomatoes and peppers, children cycling along canal-side roads, and solar panels glinting under the sun, all powered by the same sea that once seemed unreachable. The transformation of the Negev has also reshaped Israel's national identity. Once defined by scarcity and struggle, the country now sees itself as a pioneer of sustainability. Its universities and research centers attract scientists from around the world to study water technology, renewable energy, and desert agriculture. The Negev, once an obstacle, has become a classroom for humanity's future. When you trace the journey of this project from start to finish, it feels almost poetic. The sea, once too salty to drink, now sustains millions. The desert, once silent and lifeless, hums with activity and growth. Generations from now, people will look back on the early 21st century as the moment when Israel dared to rewrite its geography. The story closes with a simple but powerful truth. Israel didn't conquer the desert by overpowering nature. It did so by understanding it. Every canal, every plant, every drop of water reflects a partnership between human intellect and natural law. The lesson it offers the world is timeless, that scarcity can be transformed into abundance through vision, discipline, and courage. By turning saltwater into life, Israel proved that technology and faith in human ability can overcome even the most impossible odds. The canals of the Negev are not just rivers of water, they are rivers of hope, flowing through a land that once knew only thirst. And as long as they run, they will stand as a reminder that with determination and imagination, even deserts can bloom.